Hello, today I'm going to talk to you about net ionic equations. And so we've now just learned that when you put an ionic solid into water and it dissolves, it also dissociates. So if we were to put Ki in solution, we'd get K ions floating around and iodine ions floating around, and they would be separate from each other. And the same is true of, PbNO3 that we have here, where the Pb2+ ions are separate, but the nitrate ions, because they're polyatomic ions, they stay together. The covalent bonds don't break apart. And when we mix those together, we get a double displacement reaction, and we get a solid of lead iodide, which is shown here by the gray and purple dots. And then there's other stuff still floating around in solution. So the K ions had to come with the iodide in order to make a neutral compound, and the same thing with the nitrate ions, but they aren't forming a solid here. So when we write a net ionic equation, we're only going to write the things that change. Sorry, so I'm going to that's an introduction, but now I'll walk you through the steps for how to do that. All right, the first thing we need to know is which of the ions are going to come together to make a solid. So the first thing I want to talk about is how to use this table. You do not need to memorize anything on this table, but you do need to know how to use it. So the things shown at the top are things that are usually soluble, all right? So in that case, when we write them, in our equation, they would be written with the little AQ at the end because they're aqueous. They dissolve in water, all right? And then over here are exceptions. So there are no exceptions to the first ones. Anything that contains these ions will be soluble, all right? And then most of the things that contain these ions will be soluble, but there are some exceptions. All right, the bottom is the opposite. So these ions are generally insoluble. They usually form solids with other cations. Right, but then there are also some exceptions. For example, if there's no exceptions to sodium ions being soluble, then if we pair them with hydroxide or with sulfide, that would be an exception, all right? So if it's paired with one of those, then it would be soluble. All right, so let's just practice that skill first. All right, so for each of these, we're going to determine if it's soluble or insoluble. For potassium sulfide, we're going to look at our table, all right? Sulfide is here and potassium is up here, right? There are no exceptions to potassium being soluble, and the exception for sulfide being insoluble includes potassium. So that means that potassium sulfide is always going to be soluble, and we'd write a little AQ after it if we were doing our equation. All right, calcium nitrate. All right, calcium is not listed here, but nitrate is, and there are no exceptions. It's always soluble. All right, so calcium nitrate would be soluble, and we'd write the little AQ there. All right, lead chloride, PbCl2. All right, lead is not listed here, but chloride is. So generally, compounds with chloride in them are soluble, but lead is an exception, all right? So if lead is in there, it's going to be insoluble. So when we write that one, we'll have the little S after it because it is insoluble. It does not dissolve. All right, for NaOH, Na is one of those ones that's always soluble, no exceptions, right? So that one will be soluble. And then aluminum phosphate, all right, aluminum is not listed here, but phosphate is. Usually phosphate compounds are insoluble, all right? With these exceptions, aluminum is not one of those exceptions, so it will be insoluble. All right, so now let's go through an example, or let's go through the steps for how we would write net ionic equations for a precipitation reaction, or when we form an insoluble salt. So first we just figure out what the products of our double displacement or double replacement reaction is. Then determine if either of the products is insoluble. If they're both soluble, nothing happens, nothing changes, and so no reaction happens, and then you're done. There's no net ionic equation to write. If one of the products is insoluble, then you'll go through writing a full ionic equation where we dissociate any ions that are soluble, all right? But the solids will stay together because they're not dissolved, so they didn't dissociate. And then we'll cancel out spectator ions. I'll talk about what those are in just a second, and then write the net ionic equation with what's left. All right, so this is the example that we're going to do. So if we have silver nitrate and sodium chloride and we mix them together, the silver has a +1 charge and it will pair with the chloride, which has a -1. All right, remember we need to take into account the charges, which you can get from your periodic table. All right, so we have 1 Ag and 1 Cl to make a neutral compound. And then the sodium, which is +1, will pair with the nitrate, which is -1. I will give you a table with the ions in this unit, so you should have memorized them, but if they're not fresh in your brain, don't fret. All right, and so when they pair, we get sodium nitrate, 1 of each. All right, I just accidentally clicked, but we can look at our solubility chart and see that most chlorides are soluble except if it's paired with silver. So silver chloride is a solid, all right, it's insoluble. Sodium and nitrate are both ions that are always soluble, and so that one will be aqueous. All right, so now everything that's aqueous, we're going to separate into its individual ions, just like we did when we learned about electrolytes. All right, so silver will be +1, nitrate is -1, sodium is +1, chloride is -1. This silver chloride stays together because it is a solid, and then we have sodium with +1 and the nitrate with a -1. So what you'll notice, hopefully, is that we had some ions that were soluble over here and are now insoluble over there. That is a change, all right? We formed a solid. However, there's also some ions, like the sodium, which look exactly the same on both sides, okay? So they are, we call those spectator ions. They are present for the reaction. They're necessary, but they don't actually do anything other than provide a counter ion to neutralize our salt, okay? So we are going to cancel those out. So we'll cancel out the 2 nitrates, and we'll cancel out the 2 sodiums because they did not change, all right? And then we'll write what's left. So our silver ion reacted with the chloride ion and made a solid. All right, that is our net ionic equation. The one above is the complete ionic equation, where we show all of the ions, even the spectators.